Every single year, the world produces more than 20 billion pairs of shoes, and almost all of them begin the same strange way. Not with fabric, not with rubber, but with a solid, invisible plastic foot that no customer ever sees. The sneaker on your feet is hiding a secret, and the whole thing is built around something you will never actually see. By the time we are finished, you will never look at a running shoe the same way again. Pick up any sneaker, and in your hand it feels like one soft, simple, single object. But it is not one thing at all. It is a tiny machine, assembled from a surprising number of parts. So before we build one from scratch, let me ask you a simple question. How many separate pieces do you think are hidden inside one single, ordinary running shoe? 5, maybe 10. Most people guess low, and they guess far, far too low. The real answer looks a lot more like this, and it is honestly a little bit shocking. A single, everyday running shoe hides around 50 separate pieces inside of it. The most advanced performance models can push past 65, and everyone is cut and joined by hand. 50 separate pieces, all hiding inside something you tie onto your feet without a single second thought. To understand why, we have to take one completely apart, layer by layer. Every sneaker on Earth, no matter the brand, breaks down into 3 big regions. The upper, which is the part that wraps around and holds your foot in place. The midsole, the soft, springy layer hidden just underneath your foot. And the outsole, the tough, rugged skin that actually grips the ground. Stack them all up, and a sneaker turns out to be nothing but clever layers. Each layer does one specific job, and together they carry the full weight of your body. But which part comes first? Which single piece does the entire factory build around? The answer is quietly the single strangest object in the whole building. It is not the sole, it is not the laces, it is not the fabric. It is a solid plastic model of a human foot, and it is called the last. Every single shoe in the world is built on top of one of these. The last is not shaped like your foot, resting quietly on the ground. It is sculpted to the exact shape your foot makes while moving, caught in mid-stride. Get the last wrong, and every single shoe built on it will pinch and hurt. Get it exactly right, and the shoe seems to vanish on your foot. So the factory begins right here, with thousands and thousands of these plastic feet. One perfectly matched pair for every single size, and every different style that they make. Now for the upper, the part that everyone actually looks at and sees. And there are 2 completely different ways a factory can build one. The older, more traditional way of doing it is called cut and sew. Flat sheets of mesh, foam, and synthetic leather are layered together on a table. A sharp steel die stamps out each piece, exactly like a cookie cutter. Then skilled workers stitch dozens of these tiny pieces into one 3-dimensional shape. A single upper can hold well over 20 separate panels, all sewn together. The newer way of building an upper, though, looks almost like actual magic. It is called knitting, and in just a few short years it completely reshaped the entire industry. A giant, computer-controlled machine knits the whole upper as a single piece. One continuous thread, looping tighter here for support, and looser there so the foot can breathe. There is almost no cutting, barely any stitching, and almost no wasted material at all. What once took 20 separate pieces can now be a single, woven sock. The difference in raw part count is almost hard to believe. 20 odd stitch panels versus one seamless knit. That right there is the revolution. But a knitted upper is floppy and soft. On its own, it is completely useless. It has to be forced into the shape of a foot, our plastic foot. This is the step that finally gives a sneaker its form. It is called lasting. The hard plastic last is pushed deep inside the limp, empty upper. And suddenly, the limp, shapeless fabric snaps into something you instantly recognize as a shoe. But it is not nearly tight enough yet, not even remotely close to finished. Machines grab the loose edges of the upper and fold them underneath the foot. They pull it drum tight over the last, stretching out every last wrinkle and fold. Glue and heat then lock those stretched edges firmly down against the bottom. This is exactly why a good sneaker hugs your foot so precisely. Its shape was literally stretched onto a model of a foot in motion. Now the upper has a shape, but it still has no cushioning whatsoever. And for that, we move to the single most important layer in the entire shoe. The midsole, that soft white slab hidden between your foot and the hard road. This unassuming layer is where all of the real engineering actually lives. It is almost always made from a special foam called EVA. In its raw form, that EVA arrives as small, hard plastic pellets. The pellets are melted, mixed with a gas-releasing agent, and poured into a hot mold. Inside that mold, the mixture erupts, filling with millions of tiny gas bubbles. Those bubbles are the entire secret. They are trapped, sealed pockets of air. The foam expands, then it is cooled and pressed into its final shape. What comes out is feather-light, and yet surprisingly springy and alive in your hand. A single midsole can hold many millions of these microscopic little air pockets. But why go to all this trouble for a bit of spongy plastic? To really answer that, look at what your feet quietly endure every day. Every time you take a single step, your foot slams into the ground. The force can easily reach 2 to 3 times your entire body weight. Now start running, and you do that again and again, thousands of times an hour. Over just 1 mile, a single foot strikes the ground more than 800 times. Without cushioning, all of that shock travels straight up into your knees and joints. 3 times your body weight, hammering your legs with every single stride. This is the exact problem that the foam was engineered to solve. When your foot lands, those millions of tiny air bubbles all compress at once. The foam squashes down, absorbing the blow so your bones do not have to. But here is the part that turns simple cushioning into something like magic. The foam does not just soak up that energy, it actually gives it right back. As your foot lifts away, the compressed bubbles spring back to their shape. They push, returning some of that force, like thousands of microscopic little trampolines. This is called energy return, and it is the true holy grail of shoe design. The better the foam, the more of your own energy it quietly hands back to you. A basic foam might return only about 60% of that energy to you. The very best foams return over 85%. The rest simply turns into heat. That one single difference is what separates a cheap shoe from a genuine, record-breaking machine. It is why elite runners chase the perfect foam like a closely guarded secret weapon. So the real machine hidden in your sneaker is not a gear or a spring. It is a slab of foam, engineered to return the force of your own footsteps. But foam is soft, and it would shred itself apart on rough pavement. So it needs a tough, protective skin, and that is the outsole. This is the hard rubber layer that you actually walk and run on. It is molded with a careful pattern of grooves and lugs, called the tread. That tread is finely tuned for grip, on everything from smooth track to muddy trail. Harder rubber lasts far longer, softer rubber grips better. Designers carefully balance the two. Now the factory has 3 finished parts. Somehow they must become one single shoe. And for most sneakers, the answer is not stitching at all. It is glue. Powerful industrial adhesives are brushed onto the upper, the midsole, and the outsole. The pieces are pressed together under real force, and then blasted with intense heat. The heat activates the glue, fusing all the layers into one single bonded body. Step back now, and the whole strange process finally lines up in order. The last, the upper, the lasting, the foam, and the rubber. One finished machine. And here is the thing that surprises most people about this entire process. Despite all the technology, most sneakers are still assembled by human hands. A single pair can pass through more than 100 different pairs of hands. The pieces are simply too soft and far too fiddly for robots to handle well. Before it is ever allowed to ship, the finished shoe is deliberately tortured in a lab. Machines bend the sole back and forth, tens of thousands of times in a row. They twist it, soak it, and yank the glued seams apart, making sure nothing fails. So the next time you lace up, remember exactly what you are standing on. An invisible plastic foot shaped every curve, and a slab of foam is quietly handing your energy back, step after step after step.